Okay, it's time. Let's finish the numpy lectures, and you can do the assignments for your homework and able to do the lab. So finish those lectures. This Monday we were here. We finished about how to create numpy array, access each elements, and we are here at these operators, functions, and methods. And there is a philosophy change. Before those modules, we write all the things by ourselves. You write all the for loops, you create all the variables, you create your own functions. Starting from now on, if you are going to do a data scientist job, you should avoid writing those functions yourself. Instead, you should just call the functions. So for this numpy array, if you are using the numpy array, there is always a function for that to do the operation you want. And you should try to avoid writing your for loops. And most loops can be avoided entirely with proper use of numpy array operations. So that's the idea. So let's talk about those operations. There are element-wise operations, and there are matrix-wise operations. Element-wise operations, anybody can understand. Those were operates on each element in the array. So addition, subtraction, multiplication, division, exponential, comparison. So recall, this is how we create arrays. We can use a range function to identify start and end. We can convert a list to an numpy array. So we got two arrays in this way. And here are the results for basic operations. If you do addition, multiplication, you got addition, 1 plus 4 is 5. And each elements were added together. For multiplication, you just use the corresponding symbols. Division, subtractions, and square. So let's say I can move those down. Yes. Here. Oop. Okay, we have array 1, array 2. Addition is just each elements add to each other. Multiplication, 1 multiplied 4 is 4, 2 multiplied 2 is 2. Those are corresponding places. Division is 1 divided 4 is 0.25. Subtraction, 1 minus 4, you got minus -3. And for power, it's if 1 power 4 is still 1, 2 power 2 is 4, 3 power 1 is 3, 4 power 4 is 256. So each element have those operations on each other. And we can also use comparisons. Array 1 equals array 2. You would get the first element were not equal. Second are, so it's true. Third is not, so it's false. And the last item are both 4, so it's true. And also same for greater or smaller comparison. You got each element have a result true or false. So with those one-dimensional array of the same type, those could have just easily be second 2 dimensions, 3 dimensions. They all follow the same rule. So let's see this example. We have a matrix. It's just a set 2D array, 2-dimensional array with the first, second, third item, and each item has three dimensions. So 5 divide 2, 2.5. 8 divided 2 is 4. So this is element-wise division. Every item was divided by 2. And you can do every item plus 1. You can do every item power 2. So those are straightforward operations. Checking containment is like list. We can use in keyword to see if a value is in an array. So for that matrix, well, for that array, 5 is in there. So if we run this, it will say true, and -9 is not in those elements, so it will return false. So that's element-wise operations. And best thing for numpy is it has lots of functions. And it's always recommended to use functions instead of doing like your own function. The numpy functions are automatically designed to work on the array as a whole, performing the function on each element automatically rather than having to loop through the entire array. So common mathematical functions will be here, exponential, and when you are in computing field, when you are doing any programming language, by default, we will use natural log. Natural number will be the base. So if I use log, you know it's natural log. And if you need to do log base 10, you need to have write log 10 or log 2 to choose different base. So by default, everything is natural log. And it's for exponential, it's exponential on the natural number. And the functions exponential. Oh, why keeping this? Okay, absolute value, ABS, logarithms, and trigonometric, sine, cosine, rounding. You can round an array with how many decimals you want there. You can do floor, you can do ceiling. So see those examples. So those are all in numpy, so use np dot to call those functions. Let's create 2 new arrays. First array is 1, 2, 3. Second array is 10 numbers between -2 and 2. Okay. If you are still not sure, you can always print to see what are those things. So everyone see that array 2 is 10 numbers between -2 and 2. Okay, so exponential array, the first 1, 2, 3 is E natural number. Exponential 1 is still itself, so start with 2.718 and goes on and on. And if you do log 2, log base 2 for the natural number, the first one is 0. If you still recall the things. And if you do log base 2, you can do absolute value, you can do round. Round is I only want 2 digits, so I can round to the 2 nearest decimals over there. It will be the last line. Any questions here? So if you want to do operations, call the numpy functions, especially if you want to do complex operations. There are methods in numpy arrays, and all those are in documentations. We cannot cover everything here. We just see some basics. So array name is the variable name. You can define this whatever you want. And those methods names are reshape, and you can put a new shape over there. It returns a view of the data with the new shape. It does not actually copy the data, so be careful modifying values. We'll see some examples later. This is reshape. Sort, you can sort the array in place. And you want a copy, use np.sort. So those two are different. Those sort are in place. Those np.sort is not in place. You need to assign the new value to a new variable. Argument sort returns the ordering for indices that would sort the array. Cumulative sum, cumulative products, flatten as type is convert the types, and copy is returns a copy of the array. So see the example here. We create an array with 0 to 11, like here, and we reshape it to the first dimension 4, second dimension 3. So originally it's one shape. It's just a one-dimension array. And when we do the reshape, it will change the shape to this. Let's see those one by one. So if we just do np.arrange, this is one dimension, right? And if we do the reshape, it changes the view. It's not actually changing the values, it just makes it a new shape. So when you print the match, you see the new view for the array. And if you change a variable in the match, it will also change the original value in the array. So those are not two individual variables. Those are the map is based on the array. So those will be changed together if you change that. Similarly for it works very similar to the list. It provides a view instead of the real data. So one thing to remember is if you want to avoid this, do you know what we should do? If we want to change the map, but not change the array, is to use copy. So by this way, you create a new variable, a totally new separate variable. Those will not be linked together. So if you do this, you change the match, the original array will not be changed. Okay, so be careful when to use copy and when to use the reshape. Okay, there are many other things. We can create a two-dimensional array like this using a list of lists, and we can call the flatten function. So it will change everything into a one-dimensional array. This is flatten. We can do sorting. You have an array with different numbers. The argument sort and sort work differently. So run this. Argument sort returns the index. So we know the index 1 is the smallest number. Index 2 is the second smallest. Index 0 is the third smallest, and index 3 is the largest. So this returns the index of those sorted results. And the sort function returns the elements in the sorted order. And this is in place. Okay, so those are the differences between argument sort, ARG sort, and sort. And you can do cumulative sum. So array is 4, 1, 2, 8. 4. Cumulative sum is 4, it's adding itself. 4 plus 1 is 5. So the second item is 5. 5 plus 2 is 7. And all those add together is 15. This is a useful function for one of the activity. Yes.
That first array comma.
You mean this one?
1, 2, 0, 3.
Okay, so that's what here. This 1, 2, 0, 3, right? Okay. This returns the index. So this is, so index is 0, 1, 2, 3, right? So we should have what 0, 1, 2, 3 here in the results. So it tells you the index 1 is the smallest number. Index 2 is the second smallest number. Are you okay? So this is index 0 is the third smallest. The index 3 is, well, kind of the largest. So it's the last item. Okay, do you get this? So this is index. This is helpful if you are, let's say, only want to have the index for, so you know when we use indexing and slicing to access those items in the arrays, right? So index will be useful if you want to slicing something in the later stages. Now we talk about one-dimensional cases. There are two-dimensional and more-dimensional cases. We can use all those functions to specify the axis on which you want to perform the operation. This is helpful for doing things like sorting each row or column independently. For example, with axis equals 1, sort will sort each column separately. So let's say we have a table. So this is a two-dimensional array with 9 elements. The 9 elements look like that. Now we just want to sort only for each column. And we can do this axis equals 0 as a parameter for that sort function. And after sorting, the matrix will be look like that. So this is sort by the columns. See, this is 3 to 8. Now it's 2, 3, 8. This 6, negative 1, and 4. Now it's negative 1, 4, and 6. Similarly for the last column. You can do this for rows. So let's say we just want to sort down for each row. We just change the axis parameter to 1. As you can see, it changed the order for each row. 3, 6, 1 comes to 1, 3, and 6. If you don't put any parameter over there, it will just sort everything. So, question, have you observed what's the consequence if I don't put any axis parameter here? Sorry. Yes? It is sorting by row by default. So there is that default parameter. The axis is 0. That's it. So there should be no change. Oh, wait. It's sorting. Okay, so as if I don't put anything here, 1, 3, 6. 136. Okay, the default access is -1 in this version. Okay, the default will be different for each version. Actually, Python NumPy did a big change over the years. For this version, the default should be -1, and it will have the same effect as 1. Right, so all those results are the same. There is some like cautions or reminder for this is when you do something like that, like this sorting, always write specifically which axis you want to sort. So people will not be confused if they use different version of Python. So always try to write this out so people know which like sorting order you want to do, either for row or columns, or if you have more dimensions, you can sort that. Now there is a question is how do we sort element? So I want the first element to be the -1, second element to be the 1, and go on from there. Any idea? So we just talked about the flatten function. We can just flat this thing to a one-dimensional array and reshape that to the same shape as the mat. So let's call a new variable called flattened.mat flatten. And then we can have this f.sort. It doesn't matter because the axis will just be 0. And this f will have the character we want. So it always it's sorted from the least smallest number to the largest. And we want to convert this back to the mat. So we can do this f dot reshape mat the shape. So in this way, this is element-wise sorting for a NumPy array. You can first flatten that, so the sort function can work on all elements, and you reshape that flattened NumPy array to the original shape by calling such thing. Okay. Okay, so for those who are familiar with linear algebra, the multiplication should not be like that. So for a two-dimensional array, for a matrix, when you do multiply them together, that should not be element-wise multiplication. That should be the matrix multiplication in like mathematical definition, right? So instead of using those star element-wise product, so this is element-wise 1 multiply 1, 2 is 2, you should do the at or dot method. So if you use those two methods, it will be matrix product instead of the element-wise product. Right? Because if you 1 multiply 2, 1 multiply 1, 1 multiply 2, 1 multiply 3, and that is the mathematical definition for matrix multiplication. If you can use that matrix product in your activity, you will get rid of any for loop there. So in the activity for this week, ideally you will use this matrix product instead of for loop. So there will be no for loop in your activity. Okay, so element-wise and matrix product are different. And remember to use different ways to calculate those things. And this is the NumPy documentation. Always refer to those documentation in the future. It has everything. It has the new features. And for example, if you were uncertain about the sort, it tells you there are more parameters than only the axis. So you can see here, the default is -1. Kind, order, star, stable. Those are other things we don't cover in this class, but you should know there are other things. And if you look at this documentation, you should be able to get what those meanings are. Okay, that's the documentation. Last part for this NumPy lecture is the reduction operations. So those are element-wise, matrix-wise operations we talked about, and the previous operation all return array with the same shape. However, there is reduction operations go from higher dimension to a lower dimension. So it can reduce dimensions. That's why it's called reduction operations. So we can use to calculate maximum, minimum, or sum, or median, all those things. Very useful if you just want to have some basic stats for your data. So array name is, again, anything you defined. Minimum, max, sum, mean, standard deviation, argument max, argument minimum. So that returns the index, not return the values. Okay, let's look at those examples. We have a matrix like that, 5, 7, -8, 1, 3, -4, 12, 0, 1, 0, 2, 5. Because we originally have one dimension and reshape that as 4 and 3. So first dimension is 4, second dimension is 3. Okay, so it has 4, two dimension is 4 rows, 3 columns. The minimum, -8, maximum 12, sum, add all those together, just get one number, 24. The mean average is 2. And if we flatten and get the minimum index, it will be this one. So 0, 1, 2. The minimum element is at index 2. Those are all handy functions. So again, those are methods. We call them by using the array and dot method name. There is additional reduction operations. Certainly more we did not say there. Count non-zeros, counts the number of non-zero elements. If argument evaluates to a Boolean array, counts the number of true. So if it's numbers, it counts non-zeros. If it's Boolean, it counts true. How many trues are in there? Any array returns true if any match of array is true, or returns true if all elements of array are true. Median returns the median of all elements. So for that matrix, we have 10 non-zero numbers. You recall here, we only have 2 zeros. So there are 10 non-zero elements. And the median is 1.5. And if we have a true or false array, true, false, false. Any of those are true is true, and all of those are true will return false. And why we have those three different functions is we usually combine them with a logical comparison. So for instance, here, I can use this to check if array has at least one element greater than some number, or count the number of elements greater than some number. So let's say we have an array that's from 1 to 9 with some random numbers. We can say if any number in those array is greater than 6 by writing this combination of the Boolean expression and ending function. So we see this 8 and 9 are greater than 6, so it will return true. And we can also count how many numbers are greater than 6 in that case, is we can get 2. Because this return 2 truths. So it will return 1, 2, 3, 4, 5. We will return 6 elements. The 6 elements will either be true or false, right? So there will be 4 false and 2 true. So false, 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 true, false, and true. And there will be 2 true. So if you use the count 0 function, it will return there are 2 true in that array. Questions? Okay, if I print this, might be easier. And np count 0 for this array will return true. Will return 2. And we can do those things on certain axes. All of those functions take axis parameter or argument. So for that matrix, recall that matrix here. We have that matrix. If we just want to see what's the minimum number for each row, we can put axis equals 1. So the minimum number for each row, the first row is -8, second row is -4. 1 minimum for each column. The first column, the minimum value is 0, second is also 0. And by default, again, the minimum just do everything. If you don't put anything, it will reduce the dimension. It will only return 1 number, as we've seen before. So those behavior is really depends on if you put axis over there and what's the value you put for the axis. Although it's not recommended, but you can loop through arrays. Typically, we can do that by write something like that. For I in range array.shape 0, the shape 0 is how many elements in that first array, and we can do something. So Well, we can see whatever dimension in shape that is appropriate for our loop, you may want shape 1 instead of shape 0. So this can be changed. So let's see this example. We have the matrix, right? Let's say I want to add 1 to each of those elements. And you can see the mat dot shape gives you 4 numbers, gives you 2 numbers. That's the shape for its dimension. And if you do shape 0, you will get 4. If you do shape 1, you'll get 3. Okay, so if I want to loop over, let's say, the rows, for I in range, mat dot shape 0. Mat dot shape 0 is 4. We can just print to say what we have. Mat. Let's do I here. You can get each row by calling the shape 0. If you do shape 1, this will leave the last row because you only get 0, 1, 2, 3. So in order to loop over all the things, it's for I in range mat shape 1, you can print mat I. So this is how you access each element in the numpy array. By combining those numbers, and the whole idea is to get the right I and get the right index for each element in your matrix. Definitely don't do this. Well, don't try to do this in the future, but this is something you can do. There is no error. Well, this works, although very slow and not efficient. Okay. That's all for the lectures. Any questions? So for the remaining of the time, you can do the activity and try to use all the numpy knowledge. And I also opened that final project workplace. So in here, you can join your group and it will be similar for the lab. Everything will be synchronized and you can have a continuous working place if you prefer to work on parallel. I recommend to use Google Colab or somebody use Kaggle, that is fine, because in the future, your workspace will be more likely to use Google Colab, that kind of environment. Parallel is more specifically designed for the teaching and teaching environment. But it's fine if you just use those 2 workplaces. There is one extra one for some, I have a little bit different setting if somebody's computer is not working very well on the first project workspace. Okay. And that's all for today. We're also almost time.